Next topic. In previous class, we have discussed about Lenz's law and Fleming's law. Lenz's law and Fleming's law. And today topic we have to discuss about. On the completion of this topic, you would be able to know that self-induced E.M.F. and definition of self-inductance, mutual induced E.M.F. and definition of mutual inductance. In previous class, we have discussed and we have to learn, we have to know to unknown is nothing but what is the statically induced EMF, what is the self-induced EMF, what is the mutual induced EMF. All we have to discuss about statically induced EMF and dynamically induced EMF. And in statically induced EMF, two types induced EMF is there. That is the self-induced EMF and the mutual induced EMF. Self-induced EMF and the mutual induced EMF. So, what is the dynamically induced EMF? What is the dynamically induced EMF? In dynamically induced EMF, the induced EMF is produced in a conductor if a conductor are moving, the field are stationary. Conductor are moving, the field are stationary. But in statically induced EMF, whenever conductor carry, which is a current, whenever conductor carry current, the EMF is produced. The EMF is produced around the conductor. The EMF is produced around the conductor. What is the self-induced EMF? What is the self-induced EMF? Self-induced EMF is nothing but the induced EMF produced in a conductor, the current flowing through the conductor itself is called as self-induced EMF. The mutual induced EMF, which is nothing but the induced EMF produced in a coil due to current flowing in the neighbor coil, is called as mutual induced EMF. So first here, what is the self-inductance? What is the self-induced EMF? What is the mutual inductance? Today topic we have to concept on what is the self-inductance, what is the mutual inductance. So in previous class, self-induced EMF, in the self-induced EMF E is equal to N minus of N into d pi by dt, and also same thing, the E is equal to L into di by dt, where the L is called as the constant proportionality, that is called as self-inductance of the coil or conductor. Self-induced EMF. If current in a coil of N turns, it changes, the flux linkages of the coil also changes. If the current is changes in the number of turns of coil or conductor, if current will be changes in the conductor or coil, N-turn conductors or coil, then flux linkages of coil also change. So this will set up a self-induced EMF in that coil or conductor, N-turns coil or conductor. That is called as self-induced EMF. Here E equal to N into d pi by dt. E is equal to N into d pi by dt, where d into pi into N into by dt. The flux is due to current in a coil. So the flux linkages will be proportional to current. All we have to discuss in previous topic. So here the flux produced in a coil or conductor due to current flowing in the coil. So the flux linkages will be proportional to current. The flux linkage will be proportional to current. That means the current will be changes in the coil or conductor. The current will be changes in the coil or conductor. Then the flux is changes. The flux will be changes. Then this flux will be causes to set up the self-induced EMF. Self-induced EMF. So here, therefore, the E is directly proportional to di by dt, di by dt. So here V E is the constant proportionality. E is equal to constant proportionality into di by dt, where constant proportionality is indicated with the L. So the E is equal to L into di by dt, where L is called as self inductance or inductance of the coil. Inductance of the coil. So the units of L is called as the Henry. Joseph Henry is proposed to what the concept on just self inductance. So here, on the name of the, you have to propose to the inductance units is nothing but Henry. So here, self inductance. How to produce the self inductance? Here, n number of conductor is there. So r number of coils is there, which is connected to the battery, and in series with the switch. So if the switch is the closing, then the current will be flows. In n turns coil. Then the flux will be set up. The flux will be linkage. And set up the induced EMF in the coil. Here, the property of a coil that oppose any changes in the amount of current flows through it is called as self-inductance or inductance. The property of a coil is opposed to any changes in amount of current flowing through it. Is called as a self-inductance. So the every coil, every conductor which has any coil, any conductors which has some property, So that property is nothing but the property of a coil that oppose any changes in the amount of current, flowing through the within it is called as self-inductance. So that means so we have to observe in this figure. Here it serves to delay the changes in current. Delay in the change in current. For example, a coupled coil, that is the electrically separated, magnetically linked, a coupled coil. This is a transformer. Is there. a coupled coil. So this is the example for self inductance, and here on the coil, so there is a straight conductor. One of the coil is a straight conductor, the other coil is a ring is there, other coil is a ring is there. So here which ring is has the two conductors, that is a one conductor, there is a other conductor. What is the purpose of these two conductors? So the purpose of these two conductors here, if one of the conductor is connected with the source, the other conductor is connected with the load. The which is a conductor is connected with the source is called as primary winding. Which is a conductor is connected with the load is called as secondary winding. The unit of self-inductance. The unit of self-inductance. What is the unit of self-inductance? The unit of Namaste. The unit of inductance is nothing but Henry. A coil has an inductance of 1 Henry if the induced EMF of 1 volt is induced in it when current flowing through it changes at rate of 1 ampere per second. The rate of 1 ampere per second. So which is called as the 1 Henry. Okay, it's called as 1 Henry. How to define as 1 Henry? The units of self-inductance is called as the Henry. So here, how to define the 1 Henry? If the if an EMF of a 1 volt is induced in it, when current flowing through it changes at rate of 1 ampere per second. 1 ampere per second. That is the rate of change of current. Is the 1 ampere per second will be changes due to the 1 volts will be applied. Is applied. So then here it produce the 1 Henry in number of coil. The number of coil. So 1 Henry of inductance is produced in a coil. Is called as 1 Henry. Next, coefficient of self-inductance. The coefficient of self-inductance of a coil may be defined as the Weber turns per ampere. In coil, it is represented by the letter of L and in measure in Henry. So that is called as the coefficient of self-inductance. The coefficient of self-inductance is which is measured by L, and the units of self-inductance is called as the Henry. So the L is equal to N into pi by I. Here the L is equal to N into pi by I. That means where N is the number of coils, number of turns. L is the number of coil, number of turns. So here, due to the current change in a coil, so the flux will be changes. So that flux will be opposed. Then it is called as the self-inductance. The property of a material or coil or conductors which oppose the flow of current is called as self-inductance of the coil. L is equal to N into pi by I. Where N is the number of conductors, pi is the flux changes in a coil or number of turns, and current is the I is the current flowing through the conductor. I is the current flowing through the conductor. So from this expression, N into N by L by B into A, according to the relation of pi equal to B equal to pi by A. So here B equal to pi by A. From that expression, pi equal to B into A. From that expression, pi equal to B into A, and where N into N by I, sorry, L, that is not L, that is I. So N by I into B into A. But here N by I into mu naught into mu r, mu naught into mu r. But in the replacement of BA is with mu into mu naught mu r, mu naught into mu naught mu r h into A, where B is equal to mu naught into mu r into h, according to the relation between magnetic flux density, magnetic field intensity or magnetic field strength h, that the B is equal to mu naught into mu r into h. So from that expression, L is equal to N by I into mu naught into mu r into h into A. So the L is equal to mu naught into mu r into N square into A by I Henry, A by I Henry. So this is the self inductance of the coil. L is equal to mu naught into mu r into N square into A by I in Henry. So Henry is nothing but the properties. Henry is nothing but the units of self inductance of the coil. Self inductance of the intense coil or conductors. So so that is called as the self inductance. So here, what is the inductance? What is the self inductance? The property of a coil or inductance. The property of a coil or inductance to oppose to the any changes is occur. Opposed to any changes is occur in that coil is called as, due to the current flowing through that coil, due to current flowing through that coil, current flowing through that number of turns is called as self inductance of that coil, self inductance of the coil. So the mathematical expression for self inductance of the coil, L is equal to mu naught into mu r into, that is the mu naught, where mu naught is nothing but absolute permeability of that coil and relative permeability of the coil, and A by I into Henry, A into by Henry, where A is the area of cross section, I is the current flowing through the conductor, I is the amount of current flowing through the conductors. Next, the factor affecting of inductance. Factor affecting of inductance. The shape and number of turns due to the any changes is there, that is the straight conductors, ring shape conductors, toroid type conductors. So circular shape, toroid and straight conductors. So the shape of the conductors and depend upon the number of turns, So the self inductance also changes, due to the this factor, due to the following property, that is the shape and number of turns, shape and number of turns. Next factor affecting of the conductance is nothing but the relative permeability of material, relative permeability of material surrounding the coil, that means where we have to, that means the surrounding of relative permeability of the coil, that means if the coil are placed in the air, suppose if the coil are placed in the vacuum tube, if the coil are placed in the any other material, then the relative permeability will be changes, so this is one of the factor will be affecting, the rate at which the magnetic field will be changing, changes. So these are the factor affecting of self inductance, Next topic is nothing but mutual induced EMF, From that mutual induced EMF, how to define mutual inductance, So here you have to observe that this figure, before going to off what is the mutual inductance, first you have to define about the mutual induced EMF. Here the two coil is there. Coil is placed on the magnetic bar of material near to each other. So here how to define the mutual induced EMF. In previous class we have to discuss about definition of mutual induced EMF. What is the mutual induced EMF? Here if the current is flows in first coil, the flux is set up in it, the part of flux will be linked with other coil, So this common flux will be linked in both of the coil is called as mutual flux. If here two coil is there, one coil is connected with the battery and switch and resistance. Now coil 1 is connected with the battery and switch and resistance. So here when the switches are closed, so the current will be flows through the resistance and in the coil. Here the resistance is nothing but to control the current in the coil, So here if the current will be flows through the conductor, the flux will be set up. This flux will be move through the magnetic field. Here the number of coil will be connected on the magnet bar, so that field is there. So the flux will be flows from the one coil through the magnetic flux density, magnetic field. So from the one coil to the another coil, the flux will be cuts on the second coil. Then by the using of that flux, due to that flux, the induced EMF is produced. In the second coil. So here the induced EMF is produced in a coil due to the current flowing in neighbor coil. is called as the mutual induced EMF. Mutual induced EMF. So here the induced EMF is produced. We have to observe by the galvanometer. The galvanometer is connected in series with this winding. Then it will be deflected. So here the EMF is produced in a second coil, which is the directly proportional to the rate of change of current flowing through the first coil. So that is the di by dt. So the E2 is equal to m into di by dt, So where m is called as the constant proportionality, that is the mutual inductance. The mutual inductance is nothing but the property of two neighbor coil to induced voltage in a coil due to the changes of current in the other coil is called as mutual inductance. The units of mutual inductance is called as Henry. So mutual inductance is called coils of also called as Henry. So already we have to define the Henry. What is the Henry? 1 Henry is nothing but, so mutual inductance between the two coil is 1 Henry. The mutual inductance between the two coil is 1 Henry if the rate of change of current is 1 ampere per second in a coil, induced an EMF due to the 1 volts is applied to the other coil, is called as mutual inductance of one coil. Mutual inductance is nothing but 1 Henry. So this is the mutual inductance. So here we have to observe that this figure, two coil is there. In the one coil current is flowing, and second coil is the EMF E2 is produced. That is the E2 equal to minus M1 and M12 into di by dt So here, so 1 and 2 is nothing but coil 1 and coil 2 mutual inductance between the coil 1 and coil 2. So here the E1 is nothing but minus of 2I1 into I2 di by dt. That means E1 is nothing but if the induced EMF produced in a coil due to the coil 2. So here the E1 is equal to minus into second coil to first coil, the flux linkages. So here minus of M21 into di2 by dt. Here in the first coil EMF is produced by the second coil due to the current flowing in the second coil. So that is called as the E1 is equal to minus M21 into di2 by dt. If the induced EMF is produced in the second coil due to the current flowing in first coil, so where equation nothing but E2 is equal to minus of M12 into di1 by dt, where M is called as a mutual inductance. It is also called as Henry. So today we have discussed about self-induced EMF E equal to L into di by dt, and units of self-inductance is Henry, factor affecting of self-inductance, and mutual induced EMF E equal to M into di1 by dt, and the units of mutual inductance in Henry. So we have to discuss about this topic. Some question is there here. When the magnetic flux linkages in a conductor is changes, option A nothing but EMF is induced and current is induced. Both are the induced, neither EMF or nor current is the induced. So option A is correct answer. That is the EMF is induced. The units of mutual inductance. Option A is equal to Tesla, option B equal to Weber, option C equal to Henry, D is a none. So here Henry is the correct answer. the mutual induced EMF, which is equal to option A equal to L into di by dt, M into di by dt, C is equal to N into I by I, where D, option D is nothing but none. Option B is called as the mutual induced EMF, M into di1 by dt. So this is about the self-inductance and mutual inductance. Self-inductance and mutual inductance, we have to prepare, we have to learn. If any doubt is there, we have to follow the reference book, then we will be able to understand. Okay, thank you.